This is Math 1010, Intermediate Algebra, Module 5, Rational Functions, Lesson 5.5. Solve rational function applications including work and motion problems. This is the only objective of this section. Example 1. Martha can rake the leaves in her yard in 4 hours. Her younger brother can do the job in 7 hours. How long will it take them to do the job if they work together? Now, one key about this, you can tell that this is a work problem because all you're given is time. Hours, hours, question, how long? Hours. This next problem you can see right here, twice as fast, okay, and then 10 hours. Time, how long? Time. They only talk about time. Now, the motion problems will give you distance, and I'll talk about rate and time, but this is just time. The basic setup is 1 divided by time of the first person plus 1 divided by time of the second person equals 1 divided by the time together. So in this case, Martha can rake the leaves in 4 hours, so that's 1 divided by 4, plus her younger brother can do the job in 7 hours, so his second person is 7 hours, so that's 1 divided by 7. And how long will it take? How long? We don't know how long working together, so I'm going to call it t. That's our variable, t for time. So we have a rational equation. I'm going to multiply by the common denominator is 4, 7, and t, and I'm going to actually do it 4 and 7 and t. See if that will work a little bit nicer on this one. 4 and 7 and t, and here also. Make sure you're multiplying every term by the common denominator. And instead of writing it 28, I'm doing this 4 and 7 and t, because it's so simple to simplify when you do it this way. So that's 7t plus 4t equals 28. Okay, 7 plus 4 is 11. 11t equals 28. Divide by 11, and t equals 28 over 11 hours. Now, if it says round to the nearest hour or etc., then you need a calculator to go to decimal form. And this is the correct answer. All right, let's take a look at the next example. An experienced accountant can balance the books twice as fast as the new accountant. Working together, it takes the accountants 10 hours. Now that's together. So in our equation, that's the one on the right. How long would it take the experienced accountant? All right, so let's say the experienced accountant takes t hours. He's working twice as fast. So the other person will take twice as long. So let's multiply. Now this is not the lowest common denominator. Let's get the lowest common denominator, 10t. Let's multiply by 10t, this one. Times, times, times. Here the t reduces. Here the 2 and the t reduces, leaving 5. And here the 10 reduces, leaving t. So we now have 10 plus 5 equals t. That'd be t equals 15 hours. Now the other value we have of t and 2t would be 30 hours. I like to generate both answers so that depending on how it's asked, I can answer easily. How long would it take the experienced accountant working alone? Well, obviously the shorter amount of time because they're experienced. If it said how long does it take the new accountant, then we'd have 30 hours for that answer. Okay, excellent. So next example. A water tank can be filled in 5 minutes. So the first one would take 5 minutes, but it's emptied in 8 minutes. So the second one is actually negative because it empties it in 8 minutes. So positive time, 5 minutes, negative time, the 8 minutes. If the drain is accidentally left open when the tank is being filled, how long does it take to fill the tank? That's the together. If the drain and the tank filling is going on at the same time. So let's multiply by, don't need to do the negative, 40t. Now when you have objects like this, one working positive and one working negative, you'll have a positive and a negative term. All right, so this reduces to leave 8t. That's 8t plus this one reduces to leave negative 5t. And this one reduces 40. So that would be 3t equals 40. So t equals 40 over 3, which is about 10.3. 10.3. The units here are minutes. This is how long it would take to fill it up, given that it can normally go in 5 minutes, but it's emptying at the same rate. All right, let's move on to the next one. Okay, Amy can clean the house in 8 hours, so our first person takes 8 hours, so 1 over 8. When she works together with Tom, so this is the together one, takes 6 hours. How long would it take Tom working alone? Tom, we don't know, so that's the t. So let's multiply this time. I'm going to do the 8 and the 6 and the t. So that we can simply reduce. I don't like this technique if there's a t and a 2t or a t and a t plus 1, especially t and the 2t, because we don't want to get t squareds in here necessarily. All right, so 6t plus 6 times 8, 48, equals 8t. Moving the 6t to the right, and be 48 equals 2t. So t equals 24, and this is hours. I don't know what Tom is doing, but he's definitely not working very fast. Amy can do it in 8 hours. Tom can do it in 24 hours. When they're working together, it only takes 6 hours. Saves her 2 hours, even though he's way slow. Maybe she should work with him. Okay, now I want to compare and contrast example 4 and example 5. Example 4, time, time, how long, time. Only time in the problem. That's a work problem. The setups are very easy. 1 over the first person's time plus 1 over the second person's time equals 1 over their together time. Now example 5, 2 trains, time. Okay, good, time. Oh, rate, rate, distance, time. This one talks about distance, rate, and time. So that's how you can tell easily the distance, rate, time problems versus just the work problems. The work problems only talk about time. So example 5 will be the start of our motion problem review. Okay, so when at the distance, rate, time problems, I set up a table. There's 2 situations. Distance equals rate times time. 2 trains, so train 1 and train 2. They leave the station at the same time. One travels east at 11 miles per hour. Okay? So we don't know, and let's see, the other train travels west. So the fact that it's the same time, I don't know how long that is, and the question is how many hours, but I do know that they're both going to be the same time. So that's my variable. Now we also have a simple rate for the first train is 11 and the second train is 9. So our distance equals rate times time does give us 11 times t for the distance of the first train and 9 times t for the distance of the second train. Now, the last one that I filled out, I used the formula to. there'll always be one column that you can use the formula to fill out. Once you have two of the columns done, you use the formula to fill out the third column. Then the information in that third column, you set up in an equation. In this case, how many hours will the two trains be 60 miles apart? Since one is traveling east and one is traveling west, the distance is increasing by the sum of these two quantities. So we need to find out when 11t plus 9t adds up to 60. That's 20t equals 60. T equals 3 hours. In 3 hours. So going 11 miles an hour in 3 hours, that would be 33 miles. Going 9 miles an hour in 3, that would be 27 miles. And add those together, and they are 60 miles apart. We have verified this answer. All right. Next question. Okay, another distance, rate, same time, distance, rate, and time. I'm going to fill this out with the table. Okay, so we have a boat, downstream, upstream. Those are two situations. It's a single boat, so it's not like boat 1 and boat 2. Now it's one boat on two different travels, one downstream, one upstream. Okay. Now, the easy stuff, 280 miles, that's a distance. Same time, 210 upstream. So there's always one column where you can just write the numbers in that are given. Now, the rate is usually either given, like the previous problem, or it's one that you want to work out right away. Now, the speed of the boat in still water. Now, with the down speed is the boat plus the water, because you're always traveling the boat speed. The water speed, the current, speeds you up going downriver. The up speed is the boat. That's how fast you travel, but this time you're slowed down by the water because you're going against the current. When you're setting up these speeds, make sure whatever vehicle you're in, a boat, a plane, a bike, whatever, is always first, because that better be the largest number, or else you're not going upstream if the stream is stronger than you are. Okay, now find the speed of the boat. I'm going to call that x. So the down speed is x plus the water is at 6 miles an hour. And the up speed is x minus 6. So we can now type those in, x plus 6 and x minus 6. Okay, so our third column we fill out with the formula. Now the formula, d equals rt, if we wanted to solve for t, just divide by r. And this gives us the formula, the time is the distance divided by the rate. Okay, so this will be 280 divided by x plus 6. I didn't leave much space for this one. And 210 divided by x minus 6. Now the last column that you fill out, you get to do something with those two in an equation. So there'll be something really easy and something pretty easy. And then the third one you fill out with the formula. And then the last one that you do, set that up in some equation. What do we have for equations for time? Same time. These times are equal. So we have 280 divided by x plus 6 equals 210 divided by x minus 6. So multiplying by the LCD of x plus 6, x minus 6 on the left, and x plus 6, x minus 6 on the right allows us to clear fractions. This is equivalent to cross multiplying that I don't like to do because it doesn't always work. We distribute. That'll be 280x minus 1680 equals, distribute here, 210x plus 1260. Okay, move the x's to the left, the numbers to the right. That will be 70x equals 2940. Dividing by 70, x equals 42. This is miles per hour. That is a fast boat. 42 miles an hour. All right. Jet boat. Maybe hydroplaning. I'm not quite sure. So again, these distance, rate, time, set up a table. One will always just be write it in. One will be, if it's distance right in, then the rate is the next one to work out. And then the time, use your formula. The third column that you fill out, set those objects up in an equation to solve. It's the most efficient in general and straightforward, consistent approach that I've found for these. All right, have another example like this. Let's take a look. Example 7. A boat moves 28 kilometers an hour in still water. All right, so that's a rate. It travels 80 kilometers. That's a distance, upstream, 80 downstream. Total time, we're given rate, distance, and time. So we set up our distance, rate, time table. Now we have upstream and downstream. All right, so the distance is 80. That's the easy one to fill out. The next, go for the rate. 28 kilometers an hour in still water. So going upstream, they'll go 28, but going upstream, you subtract the speed of the river. So I'm going to call x the speed of the current. Going downstream, it'll be 28, the boat, plus the speed of the river. Make sure your boat, plane, canoe speed is first when you're setting these up. Whether it's an x, you don't know it, or whether you do know it, like this problem. Now for the time, time is distance divided by rate. From the equation, distance equals rate times time. So the distance divided by the rate. It's a 0, and the distance divided by the rate. Now that last column that you fill out, you get to set those up in an equation. In this case, it says total time of 7. So these two add up to 7. So we have 80 divided by 28 minus x plus 80 divided by 28 plus x equals 7. Put that over 1 if it helps. All right. So now we clear fractions. Multiplying by the LCD of 28 minus x times 28 plus x on that one, oops, on this one, and on this one. So we reduce the 28 minus x, and I'm going to write this as 80 times 28 plus x, plus here we reduce, and that is 80 times 28 minus x. On this one we have 7 times 28 minus x and 28 plus x. All right, so some work to do. In simplifying, notice we'll have a 28 times 80 here, and we'll have a 28 times 80 here. Calculating that, we have 4480. We have 80x and minus 80x. So that's actually all we have on the left side. Now I'm going to distribute the 28 minus x and 28 plus x and multiply those together. And that'll be 784 minus x squared. Okay, so I'm actually going to divide by 7 here. And we get 640 equals 784 minus x squared. Now I'm going to move the x squared to the left and the 640 to the right. That leaves me with x squared equals 144. Okay, by square root, normally I get positive and negative. So that'll be plus or minus 12. However, since we're talking about the speed of the current, we only get 12. And this is in kilometers per hour. Okay. Let's move on to example 8. A man rode a bicycle for 12 miles. We have distance, then hiked 8 miles. Okay. The total time for the trip was 5 hours. Time. If his rate when he was riding his bike was 10 miles an hour faster than when his rate was walking, what was each rate? Okay, so they're talking about rate. I'm going to call this rate walking x, so that this rate biking will be x plus 10. Those are my rates. And here goes the table. Distance, rate, time. So we have biking, and we have hiking. Man rode for 12 miles, then hiked for 8 miles. The rate of the bike is x plus 10. And the rate of the hike was x. And the total time was 5 hours. Now we know that the time is the distance divided by the rate. So this would be 8 divided by x. Total time, these two add up to 5. So we have 12 divided by x plus 10 plus 8 divided by x, and that equals total time of 5. Now on these total time problems, we have like 12 over this and 8 over this. Don't get these confused with the work problems and have this 1 over 5. That wouldn't be true. That would be the total was 1/5 of an hour, which is not true. 12 minutes. That would be very fast on a bike. All right, and a hike. So now we clear fractions, multiplying by x and x plus 10. X and x plus 10, and x plus 10, reducing at 12x, plus, reducing, here I'll distribute, 8x plus 80, and here distribute 5x squared plus 50x. Okay, so we reduce, let's see, common terms, like terms, there we go. 20x plus 80 equals 5x squared plus 50x. So if I subtract the 20x and subtract the 80, I get 5x squared plus 30x minus 80. Okay, now this does factor. First off, we can pull out a 5 as a greatest common factor. X squared plus 6x minus 16. That definitely makes it easier to factor the trinomial. Now I see an x plus 8 and an x minus 2. So out of this, 5 can't equal 0, but x could be negative 8, which makes no sense because x is a rate, or x could equal 2. Now keep in mind, we have x and we have x plus 10, so x equals 2, and x plus 10 would be 2 plus 10, 12. Okay, so 2, hiking. Let's see, this is miles per hour, mph hiking. All right, pen does not want to write. And 12 miles per hour biking. I will get there. That's the weirdest looking eye I've made today. Wow. All right. So 2 miles an hour hiking and 12 miles an hour biking. All right. So hopefully with these examples, first off, you know the difference in how to check for work problems versus distance, rate, time problems, how to set up the work problems, and now how to set up the distance, rate, time problems in a pattern of DRT table. Fill one out. It's usually one is easy. Then try to fill the rate out. That's usually the second one you do. And then work the other one out with the formula, D equals RT. And then set the last ones that you create in an equation. This is a total time problem. We also have the same time problems. Okay, that completes this lesson.